As some of you may have noticed, we have covered odd and even functions before, right? What are odd and even functions? What's it talking? Yeah, it's about a kind of symmetry, right? Yeah. Okay. So. Okay. Right. So if you have an even function, right? We would say that f of x and f of minus x, they're both the same. So if you take a value like 5 and minus 5, and you evaluate it, you'll get the same value, right? And odd functions, they have a different kind of symmetry. Morning, take a seat. Right? So rather than reflectional symmetry, which is what you get with an even function, we say you either have point or rotational symmetry for an odd function. Okay. Now, when we're talking about odd and even polynomials, okay, it's a little bit different. There's a kind of nuance that I want to get across to you, but it's very closely related to these. Okay. So when you hear this phrase, odd polynomial or even polynomial, it's actually shorthand. What it really means is, for instance, an odd polynomial is a polynomial with an odd degree. Okay, like degree 1, 3, 5, 7, 9, etc. Okay, or it has an even degree. Okay, now let's think this through for a second. If you have an odd polynomial, okay, let's just consider the simplest kind of odd polynomial, right? So just degree 1, because that's the lowest degree you can have, which is odd, right? Some odd polynomials are odd functions, right? Some of them, but not all of them, right? Let's think about this. For example, y equals x plus 1. Actually, I don't even need a y. X plus 1, okay? If that's my polynomial, this is neither odd nor even, right? Like it's not symmetrical about the origin, okay? Because it's been moved up 1. However, if I just take that 1 off the end, this is odd, right? And by extension, this is also odd, and so on, okay? So odd polynomials may be odd, okay? Right? Maybe odd functions, okay? But there is no way, no possible way, that an odd polynomial, we could twist and turn it to make it an even function, right? Can you see why? They may be odd functions, okay, they might not be, but they may not be even functions. Okay? Not ever. It'll break it. You won't actually be even, because when you've got this degree here, right, which is 1, when you put in a minus sign, okay, it's never going to be equal to itself with the positive value, or vice versa. Okay, the positive value will never be equal to the negative one. Now, taking this idea and thinking about even polynomials then, right? Even polynomials. You can see where this is going, right? Let's think of some. The classic even function that you first learn about is x squared, right? X squared. That's even, okay? But x squared plus 1 is not even. Sorry, take that back. X squared plus 1 is even. But if I change it a little different way, let's say slap a minus x on the end. Let's factorize that to see what it would look like. That's x minus 1, right? So the roots are at 0 and 1. So it's been moved over, okay? So that's no longer even. Does that make sense? Yes? That's not even, but actually we just said, right? If I move it up or down, that's still okay, right? Because it still has that reflectional symmetry. Okay, now, let's just, before we take a conclusion out of this and try and generalize, right? Even polynomials, in the same way as odd polynomials, right? They may be even functions, okay? Or they may not be. But in just the same way as we have this problem with odd functions, right? There's no way you can have an even polynomial and have it be an odd function, okay? Because if you've got, power 2, power 4, power 6, when you square it out, your negatives and your positives, it won't matter whether they're negative or positive, okay? So you're always going to go towards evenness and not oddness, right? They may not be, or maybe I should say they cannot be. That's a better way to say it. Okay. You can probably draw a nice, neat Venn diagram for this if you like, but we'll skip it for now. Now, how can I generalize? And how can I see there's a pattern here? Why can I add 1 or 5 or minus 100 or whatever, but I can't add or subtract an x or a 2x or a 3x or anything like that? Well, let's consider an example. Let's up the degree this time, okay? Let's go to, say, a cubic, okay? Now, if we consider a general cubic, yeah, that's going to be ax cubed, bx squared. I don't know what any of these coefficients actually are, okay? Now, because it's a cubic, odd degree, right? It might be odd, but it might not be, right? Let's consider as if it is, okay? Okay. Now, if it's odd, this is the condition for an odd function, right? So therefore, I ought to be able to take all of these and evaluate them in terms of these two lines, okay? So I'm going to say f of minus x. Every x, let's replace it with a minus x, okay? I'm going to get let's write it out in longhand just to make sure we don't confuse our signs here, right? B, C, and the D is independent, right? Well, that's equal to the whole original polynomial with the minus sign out the front. Okay, so every single term, all 4 of them, they turn negative. Okay, so this is going to be minus ax cubed minus bx squared minus cx minus d. Okay? So far so good. So this is just the definition of an odd function. Yes? I should say that, sorry. Okay? Alright, but I can do some evaluating over here, right? This is actually minus ax cubed because those 3 negatives turn into 1 negative. Here, that's bx squared, right? Is that okay? People think, yeah, okay. I just saw people with confused faces, so I didn't wonder if I was doing something wrong. Okay? That's what I've got on my left-hand side, right? This has gone positive. This never had an x term on it, so it stays positive. Yep.
On the right-hand side, shouldn't it be plus bx?
Why?
You make the whole thing negative.
What? Stop. What's the left-hand side? The left-hand side corresponds to this. I've substituted in minus x. That's why I've got all these minus x's here. Okay. Whereas this side is that okay. So I've switched those around. But hopefully the minus x is there makes it unambiguous which one's which. Okay. Is that alright?
B and D are 0.
Okay. Almost there. Okay. Wait. Do people want me to stop before I go any further? This side is f of minus x. Or actually it's p of minus x. Okay? Whereas this is minus p of x.
Oh, yeah.
Is that okay? Yeah? Alright, great. Let's keep going. Now, I can finish writing out this side. Okay, but because of the way the signs are, you can see I've got a minus ax cubed here and 1 here as well. And I've got a minus cx here and I've got 1 here as well. Okay? So when you add those terms to both sides, they just disappear. And in the same way, just to keep everything positive, right? I can add a bx squared and a d to both sides, and that'll make this side equal to 0. Is that okay? So when I add to both sides, here's what I end up with. 2bx squared plus 2d, that's equal to 0. Because I got 0 on this side, I can just divide through by 2. So I get this. Now, what that tells you, if you come back to your original polynomial, right, is that those terms there, right, they actually don't exist. They're trivial. Really, what I've got is this. Okay? Now, can you see why this works? Can you see why this makes sense, not just algebraically, but of course we should have expected this, right? Why is it that, here we go. These functions here, right, these two are odd, but this one's not. Okay? These two are odd because the only part that makes them odd, right? They're odd. But when I add this one is, well, one's a kind of function, isn't it? It's an even function, isn't it? So odd plus even is no longer odd, okay? Now if I've got these parts here, x squared terms will always be even. And constant terms will also always be even, okay? If I want the whole thing to be odd, I've got to get rid of those even parts, okay? And only leave behind the odd ones, right? Which is why that's what you end up with at the end, okay? Now, you can rehearse this argument if I said, let's change the degree, make it say 4 or 6 or 8, and let it be an even function, okay? You're going to get the same result, but what are you going to expect? If, say, if this is the, a, let's make it to the power of 4. Okay. If I told you that this one, I should change the name, if q were even, right? Couldn't possibly be odd, obviously, because you've got a 4 out the front. But if q were even, in just the same way that making it odd, I had to get rid of all the even terms, okay? To make sure that this is really even, I've got to get rid of all the odd terms out, okay? So if it's even, then what I'm really going to be left with is this term, that's okay. But this term's out. This squared term's okay, this one's out, and there's my constant on the end, okay? So if I want the whole thing to be even, then all of my components have to be even as well, okay? Right, now, the reason why I drew your attention to this is because in exercise 4D, I think question 12C, 12C. 12C says, P of x is an odd polynomial, and it has degree 3. Okay? And then it tells you some information about things that are factors and things that, when you divide them through, you get certain remainders. Okay? And you have to find what P is. Right? Well, you only get given two pieces of information. You get told that x plus 4 is a factor. X plus 4 is a factor. So using the factor theorem, what can I write down? What equation can I write down? If x plus 4 is a factor, P of minus 4 is 0. Good. The other piece of information is when it's divided by x minus 3, the remainder is 21. So with the remainder theorem, what can I write? Okay, good. So I've got two equations here, so therefore, in order to really be able to solve this and find out, what is P, there can only be two unknowns, two variables, because I've got two equations, right? Now, obviously, if you just start out with ax cubed plus bx squared and so on, you've got four unknowns, you can't do it. So you've got to be able to recognize this. Okay? So I would say, since P of x is odd, it is in the form, and then you just take the odd components. Okay? I'd still call them A and C rather than A and B because it gets a bit confusing which one you're talking about. Okay? And then you just take these and you solve it like you normally would. Okay? Two unknowns, two equations, off you go. Does that make sense? Okay. So some of the trickier questions in that 4D exercise toward the end, they're deliberately going after this idea. So if you, I think in some senses, because like we mentioned, you've covered odd and even functions before, you already knew what this definition was. Some of you might have gotten here on your own steam, but if you're a little confused, you're like, how can I possibly work out what A, B, C, and D are? This is what you need. Okay?